Today I am going to explain about fabrication process of a single-sided PCB board. As we know that first we need to design a schematic in a schematic capture of a DPRESS software. So once we finish this design, we need to do verification. So once no error is found, then go for convert PCB so that it will move to layout software. I mean PCB layout window. So here we need to do traces as per your schematic diagram. You need to do traces from each component, or you can do auto routing or auto placement as well. Okay, so this is we already done. This is your 78005 or 7812 regulated power supply. Okay, so once traces is done in bottom layer, so you can see that the green color indicates the component footprint, and this blue line indicates the traces, and these are the pads. So while drawing traces, you need to select bottom layer and you need to do the traces. Okay, once the trace is done, after that go for board outline and place the board outline completely, and then go for copper pouring. So already done, just I click here, copper pour. So this is what we done. Up to this is designing of schematic and as well as PCB layout. So once we finish the layout design and copper pouring, okay, you can copy multiple multiple copies just by selecting and copy paste. So you can do in a single sided PCB board, you can do many RPS 1, 2, 3 like that. So once we done with this number of copies as per your requirement, okay, next process is you need to give print. So go to file and check the preview first. Okay, this is the preview. Here you can select different layers under the object. Means you can check what are the pads, holes, traces, copper pour. So for individual object layer, you can generate separate file that we can call it as a Gerber file. So I will show you one by one. So this is we can move this board by clicking this like this, so that we can adjust for the print. And print scale always should be 100% while giving a print. Okay, so by zooming you can see all the layers here. I will show one by one. So here you select all the layers and remove copper pour for better visualization of traces and pads. Okay, I will remove this copper pouring. Yes, so this is the complete PCB layout diagram. So this is the traces and these are the component footprints. Okay, so here you can check pads. Yes, you can check the pads, changes in the pads. Those are all pads. So wires we are not used, leave it. And holes, so where you can drill the for lead insertion. Okay, this is holes. So we have 1 mm drill bit to drill this particular pad. Okay, and then you can check the traces. Okay, next silk screen indicates the description of the individual component footprint. Silk screen. So this is about all the layers, object layers in this. Okay, we will give print. First you just remove the copper layer, and this you can give print. Print scale should be 100%. You take all the layers for reference so that you can identify where the component it is. So now print scale is 100% and go for print. So after clicking print, we got this. So here you can see the traces and component packages, so that while drilling you can identify easily by comparing with this diagram. So that's why you take this printout in normal paper before proceeding for photo paper. Okay. Yes, once it is done, next you can go for you can do adjustment as per your requirement paper. This is a tool used now. So now actually in photo paper how we can print, let me explain. So here after selecting all layers, copper should be added. Where is that? Yes, I think copper core, and remove silk screen. Okay, and as well as board, and you select your current layer. So this is the thing we need to take a printout. This is the bottom layer. It consists only pads and traces. Okay, and the one more thing is here, whatever we done in PCB layout, it is in normal. Components will be normal side. Okay, while giving print on photo paper, you need to click here mirror, so that it will reverse that. Why? Because after taking print on the photo paper, while we are placing like this, again it will be come back to same positions. So that's why we need to do mirror here. Now it is ready to print. So I am giving print now. So this is my photo paper, or we can say it is a glossy paper. Okay. So now let us give print on a photo paper. I have selected 2 copies of RPS 7812 power supply. So I am placing as per our requirement. So print scale should be 100% while giving print. So just I will click on print. So you can select here portrait size and then go for print. So it will print on photo paper. So this is how we got in photo paper. Here I make that ground to the copper, so that ground is common in our PCB board. So this is 7812 regulated power supply. Okay, next process is we need to transfer this image into PCB board, single side PCB board. Just you place like this. Okay, and we need to transfer heat from the iron box. Okay, after up to 2 to 3 minutes we need to pause the heat, so that image will be transferred to your PCB board. Okay. So this is the RPS regulated power supply image. This we need to transfer to the single side PCB clad sheet. So before transferring this to here, this we need to scrub the PCB board, so that we can remove all the particles, dust particles. So this is how we need to do. So the copper get cleaned for a better result. Now clad sheet is very clear now. So now I will place this image. I will transfer to this PCB clad sheet. So this is how we need to do. Okay, now I will transfer the heat from iron box. Okay, so now the iron box is get heated. Now I want to transfer heat on this photo paper. So gently we need to press, so that the image will get transferred due to the heat. So we can observe. After 2 to 3 minutes transferring the heat, now I will check whether the image is transferred or not. Yes, the completely image is transferred, successfully done. Okay. So now it is little bit heat. Just put some water so that it will get cooled. So after cooling this copper clad, okay, now you can check that if any traces is etched out, use a permanent marker and draw a trace using this permanent marker, so that the trace should be get continuity. So here in my PCB board, here the traces will be very clear and no need to draw this permanent marker ink. So here you can observe that there will be some ink is missed out. So for that reason I am going to use this permanent marker to draw the trace, so that copper will be retained back while etching. This is the process. Okay. So after transferring the image over the single-sided copper clad sheet, okay. So in next process is etching. So before etching process, I mean removing unwanted copper. So first cut the circuit where the portion of the board is covered, so that etching will be faster. So this is how we cut the PCB board through this axa. Once we cut the portion of the circuit in a copper clad sheet, next process is etching. Okay, so here we are using, for etching we are using ferric chloride chemical. Okay, so we need to make the solution such a way that 1:3 ratio. So here we need to use water and this ferric chloride mixture of 1:3 ratio. So by making a solution, we will put this board inside the solution, and we need to do shaking for the removing of copper. So etching is nothing but removing unwanted copper, means it will completely remove the copper wherever it is opened. Wherever block area is there the copper will be retained. That means wherever copper pore is there the copper will be retained and other copper will be removed after etching process. This is will take 1 to 1.5 hour. The process will take 1 to 1.5 hour. So for faster etching, you need to shake the bottle, that mixture. Okay. So I will prepare this now. So I will use water. Okay, this is fine. Next I will put ferric chloride. This is the ferric chloride. Okay, I'll put some water. I will place the board. Here is the board. Can I see this? So now, we are mixing ferric chloride with water of 1:3 ratio. Now we need to do shaking to remove unwanted copper. So don't use bare hands, better use hand gloves. So now we will do shaking. Okay. Okay. After etching process, this is the the board appears like this. Now we need to remove this paint on the trace, so that we will see the copper. So for that reason we are using CP thinner or acetone. So this is a paint remover solution. So by making use of this, we can remove the paint, or we can remove the toner, so that we can see wherever there is a trace, there we can find the copper. So this is regarding copper pouring we have put, and here for the trace we got copper is left out. So now we can cross check the continuity by using multimeter later. Now we will check the connectivity of the trace and ground, common ground. Okay, first check the common ground. So here there will be 3 pins here. Pin number 1 7805, and pin number 2 is common ground. Check that. So complete this area makes as a ground. The second pin is connected to the ground pin. Yes. Now check connectivity of other traces. Yes, that is correct. It is connected. Okay. Yes. Fine. Yes. Okay. So we make ground as common through this for this copper pouring. So now, after completely removing this paint or toner over the copper trace, okay, next process is drilling. So we're using a manual drilling machine. So drill bit size is 1 mm. Okay. So wherever there is a pad, here we need to drill this hole so that we can insert the component for soldering purpose. Then later on we do testing. So let me start with one. So almost all pads are drilled. So after drilling, it will be look like this. So all the pads are drilled properly. Next process is inserting the components, soldering, and then final testing. Okay, so we have done single-sided PCB fabrication process. That is, the circuit is 7812 regulated power supply. So our student has done this soldering after completion of etching process. Okay, we have tested each component and grounding as well. So everything is okay. Once done with the testing, we are applying AC voltage, that is 12 volts. Okay, this is rectifier module, and this is capacitor for filtering purpose. So we are using 7812 regulator, and we have connected LED for indication of output voltage. Okay, so now I will switch on the power supply after testing. Yes, LED is glowing. So we have done this. The circuit is successfully fabricated on single-sided PCB. So LED indication, the output voltage will be 12 volts.